Hi there, this is problem number 35 in section 3.3. We're going to use the first derivative test to see if we can figure out what this function looks like. This is a little bit harder, a little bit more complicated, maybe more like a test question. So let's differentiate it. Probably use the quotient rule here. So if we call f x squared and g x squared minus 9, we can see that f prime is going to be 2x and g prime will be 2x. Is that right? Okay, so f prime and g prime. And then the derivative, y prime, is going to be low d high, so it'll be g prime f minus high d low, kind of blew that, low d high minus high d low over g squared, okay? So low d high minus high d low. So let's put that in here to the formula and see what we get. So f prime is going to equal g, that'll be x squared minus 9, times f prime, which will be 2x, minus, then we take f, which is going to be x squared, times the derivative of g, which is going to be 2x. That's going to be all over x squared minus 9 quantity squared, okay? This is a minus, sorry. And the critical thing about that denominator is when you square it, that's always going to be positive. So this denominator is never going to be negative. It can be 0. We can make it 0, but you can't make it negative. So let's simplify this a little bit. So it's going to be 2x cubed minus 18x minus 2x cubed all over that x squared minus 9 quantity squared. So the 2x cubes are going to cancel there, aren't they? So we've got f prime is going to equal negative 18x over a positive number, x squared minus 9. So is that ever going to, are there any critical points there? So here's the critical points, remember. Critical points, f prime equals 0. So what will make that equal to 0 means negative 18x. Negative 18x. If you want to make a fraction equal to 0, you have to make the numerator equal to 0. So what we have to look at is negative 18x. So that's going to occur where x equals 0. So that's a critical point, where x is equal to 0. First derivative will be 0. And then where is it undefined? Well, it's going to be undefined where the denominator is 0. And how you make the denominator 0 is if x squared minus 9 equals 0. So denominator, or the function f prime undefined. Let's write it like that. Okay? Where x squared minus 9 is going to equal 0. And that's going to occur where x is equal to plus or minus 3. All right? So we've got 3 critical points, 0, plus 3, and minus 3. So if we make a graph of that, let's graph that and see what's going on here. So I've got a critical point here right at 0. We put a little arrow there for critical points at 0. We've got one at negative 3. So we put another arrow there. And I've got one over here at positive 3. An arrow there. Okay, so there are critical points that divides the x-axis into 4 regions, 1, 2, 3, 4. And we want to see what the first derivative is doing in each of those regions. So here's f prime, do it in red, f prime over here, so let's see what f prime at negative 4 is. So we're going to put it into this equation right here. And we can see this pretty easily. We don't actually have to evaluate the derivative because the denominator will definitely be positive. The denominator will always be positive. The numerator, if I have a negative in there for x, is going to be positive. So it's going to be positive over here. All right, in that interval to the left of negative 3, the first derivative will be positive, which means the function is going up. In this region here, let's see, f prime would equal -1 maybe. And the denominator again will be positive. The numerator is now going to be positive also, right? -18 times -1, this will be positive. So the first derivative will be positive in this region. Let's see what's going on at f prime when x is equal to +1. You can see that the denominator will be positive because it's squared. The numerator will be negative now. So here the numerator, or the first derivative, is going to be negative. So the function is going down at this point. At this point it's going up. And lastly, let's try something over here. You know, what's going on over there. Let's see what f prime is when x equals 4, maybe. So denominator positive, numerator negative, because -18 times +4, so this would be negative. So it's negative over here as well. So going down over here. Okay? So it kind of looks like this. Over here to the left of the y-axis, the function's going up. There's something strange occurring here at -3. And then over on the right side of the y-axis, the function's always going down. So you have to think, you know, what exactly is going on there. And we'll talk about that in a second. Let's see what's going on right at 0. If I put 0 into that first derivative, what happens? The denominator's okay. You know, it's just 9 squared, well, it'll be 81. -9 squared would be 81 in the denominator. The numerator, though, is going to be 0. So right here at f prime at 0, the first derivative is going to equal 0. So that means that there's a horizontal line there someplace. We don't know where. We can figure out where, though, if we put 0 into x here. If I put 0 in for x in the original function, I know f of 0 is equal to 0 because that numerator is 0 and the denominator is -9. So the function looks like it's right here, and it's got a horizontal tangent line there because the first derivative is equal to 0 and it's defined and everything. So my guess is that it comes up like this and does something like that, right? So it's 0 right here. It's going up to the left, going back down to the right. So right there at the origin, it must do that. And it makes sense that it kind of goes down all the way till it gets to this point here. So these points, if you look back at the original function, that plus or minus 3 in the denominator will make the denominator 0. So those are going to be vertical asymptotes. So these are vertical asymptotes here, and that kind of makes sense. We've talked about that before. So what's going on over here where the slope is always positive? My guess is that it's like this. Is there a horizontal asymptote here? So remember that the leading coefficients here, the degree of the numerator is the same as the degree of the denominator. And so the horizontal asymptote will be at the ratio of those leading coefficients. And the ratio of leading coefficients is going to be 1. So right here, there's going to be a horizontal asymptote at +1. So this will look something like this. Okay? And we can verify that with a graphing calculator if you'd like. All right, so try that, and we'll talk about it tomorrow.